Welcome everyone to the part 4 of Java day 14th session. In the last session we talked about the concept of an array list. Today let's start with a new concept, vector. So what's a vector? Vector class, which is provided by Java people, is exactly same like an array list. There is not much difference between an array list and a vector. The only important difference between an array list and vector is synchronized and array list is not synchronized. Now what does synchronized word means? This is something which you're gonna learn in the sessions known with the name threads. So right after Java collections framework in Java, you're gonna learn Java threading framework. There you're gonna learn everything about this synchronized word. For now, what you have to understand is an array list and vector both works in the same way, except that vector is synchronized and array list is not. Okay, and what is synchronized? This is something you're gonna learn later in your Java threading framework sessions. Apart from this important difference, there's one more difference between an array list and a vector. Now what is that difference? The difference is, in case of an array list, what happens? Let's say you have an array list which has a capacity of say 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Let's say you have an array list which has a capacity of 10. So what happens here? Once you fill up elements in this array list fully and you try to add one more element after you fill up its capacity, what happens behind the scenes? Behind the scenes, what JDK does, it checks the capacity, and whatever is the capacity, whatever is the current capacity of an array list, it just takes 50% of that and adds that like this. So here its capacity was 10, so it's going to add 5 more. It's going to add space for 5 more items, 1, 2, 3, 4 and 5. So that's how it's going to do, right? So it's always going to increment its capacity by 50%. JDK is always going to increment the capacity of an array list by 50% of its current size upon getting filled up when you're trying to add one more element to that. So this is what happens in case of an array list. Now in case of vector, what happens? This 50%, whatever we observed in array list, this exactly is 100% in vector. That's it, nothing more. So if you have a vector which has got space for 10 elements, say 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10, and you fill up all spaces in that and you're trying to add one more element to that, then behind the scenes what JDK is going to do, it's going to increment its capacity, capacity of a vector by 100%. So it's going to add space for 10 more elements, 4, 5, 6, 7, 8, 9 and 10. So that's what it does. So vector is always incremented by 100% when you're trying to add a new element at the time when capacity is filled up, and it does the same by incrementing an array list by 50%. So that's another difference. So what are the two important differences between a vector and an array list? A vector is synchronized and a vector always is incremented by 100% when its capacity is filled up and you're trying to add a new element to that. In case of an array list, you would say that that's not synchronized and that's always is incremented by 50%. Yeah, so these are the two significant important differences between an array list and vector. And apart from these two differences, there's There's not any important difference between an ArrayList and a vector. So wherever you are using ArrayList, you can make use of a vector class. Wherever you are using vector class, you can make use of an ArrayList class, right? So let me very quickly show you programmatically how you can make use of a vector. Alright, so this is the demo that we saw in the last session regarding an ArrayList. We created an ArrayList, then we added all elements to that, then we iterated through the ArrayList, then we sorted it, and then again we iterated through that sorted ArrayList. We removed an element from the string ArrayList, and if we wish to get an element which is there at a specific index, we can get that using get function. The way an ArrayList works, same way vector also works. I've written already a demo for the vector, so let me copy this and take it to our demo, and here let me show you how you can make use of a vector class. Well, if you observe, the way you use ArrayList, same way you have to use vector. There's typically no difference between an ArrayList and vector. Everything is same, except that here when you are creating the object of an ArrayList, you write here ArrayList, and here when you are trying to create a vector object, that time you write here vector, and typically everything else is going to remain same. So if you have to make use of a vector instead of an ArrayList, then you initialize, then you create an object of vector like this. So here you have created a string vector object. This is the way to add elements, string elements to that. And then if you wish to iterate through the elements whatever you have included in vector, then you have to write this piece of code, which is exactly same, guys. If you observe, there's nothing much I have done. Every line here, whatever I've written, is same like whatever I showed you in case of an ArrayList. Not even a single difference. The only difference is this first line. Instead of an ArrayList, I'm making use of a vector, because there I was creating an ArrayList string object, and here I'm creating a vector string object. Everything else is same. Now if you want to sort the vector, then this is the way, which is exactly the same way as you observed in case of an ArrayList. So it's going to automatically arrange elements in the ascending order, and then if you iterate through the vector again, then it's simply going to then it's going to simply get you elements in the ascending order, because you have made a call to this before this iteration. And if you want to remove any element from the vector, well, this is the way to do that, remove, and that index name. If you want to get any specific element present at any specific index, then this is the way to do that, guys. If you observe here, this piece of code, whatever I'm showing you in case of vector, this is exactly same. Again and again I'm saying. So with this, I'm just conveying to you, if you have learned ArrayList, well, there's nothing new that you can learn in vector, because everything you have learned in case of ArrayList. It just, you need to know how to make use of a vector. And when I'm saying that it's exactly the same like an ArrayList, then there's nothing much you are going to learn here. Everything you have already been knowing about vector before even touching that, because you were knowing ArrayList, right? The only difference is, in case of an ArrayList, we create an object of an ArrayList, but in case of vector, we create an object of a vector. The way I showed you things in case of the string vector, same way you are going to create a vector for integer. See, syntax is going to be the same, you specify the name of Java collection, and then you specify the non-primitive type, and then the name of the object, new, name of Java collection, that could be an ArrayList, that could be a vector, and then inside it you specify non-primitive data type. Let me show you here. So this is the vector. Y vector we have understood. Y vector, the only difference, the only reason why you are using vector because it's synchronized and its capacity is increased by 100%. That's the only difference. And if you eliminate these two differences, if you eliminate these 2 points in vector, then it's exactly the array list. There is no difference between an array list and the vector. Okay, so now y vector, whenever you want to make use of things in synchronized environment, then you make use of a vector, and that's it. And well, this is a drawback. When its capacity is increased by 100% or some percentage, I mean that is not the criteria why anyone is going to choose vector or an array list. So this could be a significant point which you are going to consider when you are going to choose an array list or a vector. And what is this all about, we're gonna learn in the next session, about Java threading framework, when we're gonna learn. And this is the syntax what I just showed you, and everything is same. Whatever I talked about in the array list, everything is same except this point. So this point is what I talked about. Rest everything is same, guys. This is different here and this is different, means these 2 points are different in case of vector. Alright, so here same way you have to use the vector for integers. You have to add elements like this, then iterate through the elements like this. If you want to sort that out, you have to sort that like this, and after that you are iterating again, and then to remove you have to use this way. In order to get an element you have to use this way. Again, I'm saying, guys, this is exactly same the way I showed you over here, no difference at all. Now let's talk about the user defined object. Well, here also things are same. You create a vector for a user defined type country like this, you go on adding elements to that, you go on iterating to that. It's going to maintain insertion order the way it works in the array list, same way. And then when you're trying to sort that, then you have to either make use of a comparable interface, in the countries object, right? Or you have to provide explicitly comparator here also, the way you provided in case of an array list. Exactly same, nothing special here. So the way you use comparable and comparator interfaces in case of an array list, same way it works in case of the vector. Alright, so here also it's the same, and then you are iterating through this rearranged order, and to remove you have to use this, and to get you have to use this. Alright, so this is how a vector class works. Now if in any real-time situation, if you have to choose an array list or a vector, then you would choose a vector only and only when you are going to work in a synchronized environment. Otherwise you are going to choose an array list. Vector performs one addition thing known as synchronization, and because it does that, it takes a little more time, it's little slower than array list because it does synchronization also. So if you are not requiring synchronization, then use array list. If you are requiring synchronization, then use vector, because when you are using vector, because it has to perform one additional task, synchronization, every time, so it's comparatively slower than array list. So always make use of an array list in your projects, but if you have to use synchronization, then you have to use vector. There's no choice. And what is synchronization? Well, you cannot learn that today. You have to wait until I talk about Java threading framework. Alright, so this is all about the vector. Okay, see, if you look at the slide, if you look at this presentation, everything is same, not even a single change, except that I'm using here ArrayList word and here I'm using vector. The only difference is synchronized here I've added, and here there's no synchronized. Here I've specified 50% and here I've specified 100%. That's the only difference. I guess that's enough, right? You are with me, I know. Cool. So let's proceed, guys. So what's next? Let me clear this screen. Alright, so we have talked about an array list. We have talked about the vector. Now what is this stack? Let's talk about this stack. Guys, many times in our Java project we have to make use of a container which is going to allow us to work in a very specific manner. So let's say here is a variable, okay? Here is some variable, some container where you are going to add things. Let's say you have added 10 to it, and then you have added 1 to it, and then you have added 2 to it, then you have added 200 to it, and then you have added 500 to it. Now this is a very special container. The property of this container is that when you add elements to that, the order which you are going to follow to add elements is very important for this container. So what happens when you want to retrieve elements from this? So what it does, it allows you to retrieve only the last element what you have added to that. Are you getting my point? So if you have added 10 and then 1 and then 2 and then 200 and then 500, and once you have added all these elements, you want to retrieve elements out of this. Yeah, you want to retrieve elements out of this container. Then what it gives you, the restriction is adding is okay, but restriction is when you want to retrieve any element from it, it's going to allow you to retrieve only the last element what you have added. So you can retrieve the last element, that's 500. And once 500 is retrieved, then you can retrieve 200. Once this is retrieved, this is removed from this container, then you are allowed to retrieve 2. Means only the last element of this container you can retrieve. So this is something known as a stack. So this is a very special container. This is a very special Java collection where you are allowed to enter as many elements as you want, but the important point what you have to understand is when you want to retrieve elements out of it, then you are not allowed to retrieve any other element except the last element. You are only allowed to retrieve the last element. That's the criteria, that's a restriction. So whenever you find a need of such a container in your Java project where you want to add elements, and when you want to retrieve elements, your requirement is to retrieve only the top element, and the element which is which you have added at the last position. If you have the requirement in your real-time project, then you have to make use of this stack Java collection. All right, so let's very quickly see this also. So we have seen ArrayList, we have seen vector. Now if we have to make use of a stack, then how to make use of the stack? Well, the way to make use of a stack is also going to be the same. You have to use stack, and then you have to specify the type. Let's say you are using it for storing string elements. Then you have to provide the name of that stack object. Let's say this is the element, this is the name that you have provided, the new, then stack string, and that's it, guys. So if you want to create a stack for string, use string. If you want to create a stack for integer, use integer. If you want to create stack for a user defined object, use that user defined object, like country I showed you. And then how to add elements to that. In case of an array list, you are making use of its add function, right? In case of vector also, you are making use of its add function. Now here, if you want to add an element to that, then what you have to use? You have to make use of its push function. Here you have to specify that element. Let's say I want to add a string Ankush. Yeah, so you go on adding elements to it using push function. So here you are adding using add in case of an ArrayList, in case of a vector, but in case of a stack you have to make use of the push function of it. And how to retrieve an element from the stack? By making call to its pop function. So what this pop function does, it's going to retrieve the last element of the stack. So this is what it's going to do. In case of ArrayList and vector, how you were doing, how you were retrieving any element, you were retrieving any element using get function, right? So here how you are going to get using pop function. Okay, so this is the only difference between a stack and ArrayList and vector. Okay, cool. So let me show you this working. So here we looked at the demo for vector. Now let's look at the demo for a stack. So here let me copy this stack test demo. Let me paste it here. Guys, please be very attentive. Don't try to remember things, just keep up the pace with me. You are not required to remember things, by forcing yourself to remember. You are just required to understand the logic that I'm trying to explain you, and once you have understood the logic, then you are required to learn, then you are required to remember all that what I'm explaining you today, what I'm showing you today through practice, right? That's the only way you have to remember things. Otherwise, don't try explicitly, to remember things. Remember things using practice only. Remember things through practice only. Okay, so let's now look at the stack. How to create a stack? Well, this is the way. Stack. Why stack? We have understood. Because in our project we want some Java collection which will allow us to add as many elements as we want, but when we want to retrieve any element from it, it should pose us a restriction that it should allow us to retrieve only the last element of it. Okay, that's the reason why we use stack. Alright, and what is the syntax for that? This is the syntax. Work says philo. What does it mean? It means when you go on adding elements to it, let's say 200, 300, 500, then what it means, you are going to add elements, first element, then second element, then third element, then fourth element. It's going to allow you to add elements to the to it, but you can only retrieve the last element. So that's something called as first in last out. Right? So this works using the principle first and last out. Means if you have included 2 here, which is basically the first element, so its stack is going to allow you to retrieve this element last. You included here 50, 500 at the last position. So whatever you include here at the last position, you are allowed to retrieve it at first position. So this works on the principle known as philo, first in last out. Whatever you are going to include first, that's going to be taken out, that's allowed to be taken out in the end, at last. Alright, so this is what philo means. And this is okay, allows duplicate elements and synchronize. The way vector is synchronized, same way stack is also synchronized. Now what does synchronized means? So we're going to look at in the sessions for Java threading framework. Okay, so let's very quickly see it programmatically. This is how we create a stack object. Then using push, we are going to push string objects to it, and we can make use of an iterator with this. Okay, when we make use of an iterator this with it, it's going to allow us retrieve elements in the order we have added to it. We have added Ankush to it first, and then Gaurav, and then Gontu, and then series, right? So when we make use of an iterator with a stack object, it's going to allow us iterate through elements in the order we have included elements in the stack. Same way like ArrayList, same way like a vector. But when you make use of a pop function with that strings, that time what it's going to do, it's going to allow you to retrieve elements the way stack works. And how stack works, it's going to allow you to retrieve last element. Once that is retrieved, then you are allowed to retrieve the last element of it till the point the whole stack is empty. When you make a call to pop function, what it does, it's going to basically remove the last element from the stack. It's basically equivalent to remove function. The only difference is in remove function, what we looked at in case of ArrayList and vector, we specify the position which we want to remove. But here when you use pop, it's going to remove the last element, so it's always pointing to the last index of the stack. That's all about it. Alright, now the way we looked at stack for strings, same way you can make use of stack for an integer. Nothing special. See, I pushed elements to the stack, integer objects, and then I iterate through this integer stack. When I iterated through this integer stack, it showed me elements in the order I inserted integer elements to that. That's it. Same way like an ArrayList and a vector. But when I use the pop function with the integer and I ran a loop for that, it actually allowed me to pop up to retrieve the last element. And so I ran this loop for how many times? I ran this loop for integers.size, means whatever. So I added here 4 elements, so integers.size is going to give me the size of this stack, which is nothing but 4 here. And then I iterated through this integers.pop for 4 times, and it every time it gave me the last element of that stack. So it's going to allow me to retrieve the last element using pop function, the way it worked in case of string stack. The way I showed you things for a string stack or integer stack, same way you have to make use of things for a user defined object stack like country. So you add all elements like this. If you iterate through the stack, it's going to allow you to iterate through this stack in the order you added the country objects to this using iterator. But when you make use of its pop function, that time what it's going to do, it's going to simply retrieve the last element of that country stack. That's all about it. There's nothing special here, guys. So whatever I explained you for string stack, same thing is applicable for an integer stack, and same thing is applicable for country stack. There's not any difference between these. See here, when you're displaying using iterator, it's going to display things the way you added things in it, Ankush, Gaurav, gontuseries. But when you displayed things using pop function, then it worked in a different way. Whatever element you added last, it displayed that first. Series, Gontu, it displayed second. Gaurav, it displayed third, and Ankush, it displayed in the end. So first in, last out, right? Same is the case with the numbers, and same is the case with the user defined object country. So my question to you is, when you have to use stack? Well, you have to make use of a stack only at that point of time when you feel in your Java project you want this restriction, first in, last out. If you have such a restriction, then make use of a stack. If you do not have such a restriction, then don't make use of a stack in your Java program. Alright, and one more important point is stack is synchronized the way vector is synchronized. Okay, and what is synchronized? Well, we're gonna look at it in the Java threading framework session. Now, important point what you have to understand is, we have so far looked at an array list, we have so far looked at vector, and we have looked at stack. All of these, array list, vector, and stack, internally works on the principle of arrays only. So what they are going to do? Internally they are arrays only. So whatever I explained for an array list, right, it creates an array of size 10 in the beginning, and then it goes on increasing its capacity by 50%. Right, this is true for an array list. In case of vector, what I said, it's going to increase its capacity by 100%, which is true for vector. And then in case of stack, what you have to understand is it's also working using the same principles. The only difference is when it creates an array of any specific type, maybe string, integer, or any user defined type like country, it also increases its capacity by 100%. So that's what you have to understand. Vector and stack exactly are same. The only difference between these is, in vector there is no restriction, but in stack there is only a restriction that you are allowed to retrieve only the last element, but in vector there is no as such any restriction like that. Guys, one thing what you have to understand, stack allows you to retrieve only the last element. It works on the principle of first in and last out. That is the only thing that you have to remember, and rest it is a vector only. Alright, so this is what you have to understand for an array list, for a vector, and for a stack. Now what is next? Well, next is something called as a linked list. Now what is a linked list concept? Let's first try to understand the linked list concept, and the way we make use of a linked list is also going to be the same as we saw in case of an array list or a vector or a stack. Yeah, we have to use it in the same manner. We have to create a linked list object, like using this syntax, which you would find same like what we saw earlier. And then we have to add elements, we have to retrieve elements, we have to iterate through elements, we have to remove elements. Everything is going to remain same the way I showed you things earlier. But the only difference is the way all other concept works and this linked list concept works. So array list, vector, and stack all uses arrays concept internally. Right, and linked list basically doesn't use an array concept. It works on the principle of a linked list. So linked list Java collection works on the principle of linked list. Array list, vector, and stack all works on the principle of arrays. Linked list works on the principle of a linked list. Now what is this principle? We're gonna just look at that, and once we look at that principle, what next we are going to do? We are going to see it programmatically. We're just gonna look at its demo, which will be same like I showed you in case of an array list, stack, or vector, but you have to concentrate on how this linked list concept works behind the scenes. Okay, so let's start. The way a linked list works is entirely different from the way an array concept works inside RAM, inside memory. Let me show you how linked list works. So when you are storing elements using linked list, behind the scenes what happens is this. Let's say this is the memory and these are the blocks in that. So the way it works is, whenever you store an element in this linked list, let's say you want to store Ankush, you have created a linked list for string type, then what it's going to do, it's actually going to occupy only two portions of it. In first portion it's going to store Ankush, and in second portion it's going to store null. What here I've done, let me explain you. Now after Ankush you want to store, let's say, Gaurav in this. Then what it's going to do, anywhere in the memory, anywhere in this RAM memory, it's going to occupy two blocks. Again, in first block it's going to store Gaurav, and then what it's going to do is going to simply here write the address of this Gaurav. So let's say this address, this memory address is let's say 1298. Yeah, this memory address we call it as 1298. So here it's going to store 1298, and here it's going to store null. Have you understood the point? So as soon as you go on adding elements to that linked list, what it's going to do, it's going to change this null to the address of the next element, and the last element's second portion is going to point to null. So here if I have to store one more element, say gone2, then linked list is simply going to take up again two portions anywhere in the memory. It's going to store gone2 and null here. But what is the previous element of this gone2? Previous element of gone2 is Gaurav. So what it's going to do, it's going to remove this null and it's going to save here the address of gone2. So let's say its address is 1758. So what it's going to do, it's going to store 1758. So the way I've added three elements in this linked list, same way you go on adding hundred, thousands, lakhs, 1 crore, 2 crore, or any limit. There's no limit. You can add elements to a linked list to any limit. And if you notice here, it's not going to occupy memory initially more than what it is requiring at that instance. So if it has to store only one element, in that case it's just going to occupy memory only for one element. And how it occupies memory? It occupies memory like this. It occupies two cells, two portions of RAM compartment. It occupies two portions of the RAM, and here in one portion it's going to store Ankush, second portion it's going to specify null, means it's not pointing to any other element. It means there's only one element there. Now if you look at Ankush and if you find some value here other than null, it means it's pointing to some other some other portion of memory, and that's going to contain some valid element in that linked list. So you would go there. By following this address you can actually go to Gaurav, and here you would check, what is the next address? Yes, there is no null. If you find here null, it means linked list is done here only. It means there are only two elements there. But if you find some address there, then you would actually go to that address. What is this address? 1758. 1758 address is this. So you would come over here. Now here there's no next element because it's null. So one element is pointing to another element is pointing to another element. What I'm calling here as a portion in the RAM, this value and address of next element, then this technically in programming is called as a node. So this is called as one node, this is called as another node, and this is called as another node. So in linked list, what happens? In linked list, this node points to another node, and this node points to another node, and this node points to another node. Because there is no further node to that, so this node is pointing to null. Null means there is no further node to that. Now this is a concept. Now whatever I have explained you here, this is basically a concept for SLL, singly linked list. Singly linked list means a node is going to point to another node, another node is point to another node is going to point to another node. So this is the concept of SLL. Now there's one more concept in programming known as DLL, doubly linked list. Now what is this concept? Let's try to understand. In doubly linked list, what happens, instead of creating a node with only 2 cells, with only 2 memory locations, it creates a node using 3. So what it does, what it stores in this, it stores the address of the previous element. So what is the previous element to this Ankush? Well, there is no element further to that, so it's going to point to null. And now here, if it is a doubly linked list, then it's going to occupy 3 cells, right? Now here, this cell is going to point to the next element, to the next node, and this is going to point to the previous element of the list. What is the previous element? Ankush. Let's say Ankush address is 78, so it's going to store 78 over here. And here also, if it is DLL, it's going to occupy 3 portions in the node. So what it's going to store here? It's going to store the address of the previous one. So it's going to store the address of Gaurav. What is the address of Gaurav? 1298. 1298 it's going to store. And there's no further node after gone to, right? So it's going to point to null. So this is the concept of a DLL. So what is SLL? Singly linked list. Singly linked list is the concept where in memory a node is created using only 2 portions. One portion contains value, another portion contains address of the next node. And if you are adding a node which doesn't point to any next node, then that is going to be null. And what is DLL? In DLL, whenever you create a node, you create a node using 3 portions. Its first portion is going to point to the previous element, to the previous node of that element. So here Ankush is first element, so there is no previous element, previous node, so I'm here writing null. And this is going to be containing the address of the next node. So here Ankush is going to point to Gaurav. What is the address of Gaurav? 1298, so you'll go here. And Gaurav is pointing to the next element. What is the address of next element? 1758, so it's going to go and hit here 1758. And now if it is DLL, you have another advantage. You can go back also. From gone to, you would know what is its previous element, because here you can find out, hey, what is the previous element? It's stored at 1298 position. So you'll go here to that position and you will find, oh, Gaurav. And here if you want to go back to the previous element of it, then you would check the previous element, address 78. So it would come over here. But this facility is not available in SLL. In SLL, you can always move in the forward direction. But in DLL, you can move in the forward and also backward. So this is the concept of a linked list. Okay. Now if you look at the concept of an array in comparison to it, what we find there. So if you create an array, say string array, what you do is you create an array, but you have to specify how many locations, how many portions. So let's say you specify 2 portions. It means you are not allowed to store more than 2 portions. And these 2 portions, how these are going to be created in the RAM? These are going to be booked initially at this line itself. This is going to be called as 0th position. This is going to be called as first position. Now you fill up or you don't fill up, these portions are going to be occupied in the RAM. But in case of linked list, see what's the advantage? The advantage is Whenever you are adding a new element, for that a new space is going to be created anywhere in the RAM. It's just that the last element of that linked list is going to change its address, forward address, to that new element what you are going to add. But in case of arrays, that's a drawback. So if you have to store 1 billion element in this, then you have to book 1 billion memory spaces here. And if you have to store 1 billion elements in linked list, then you are not required to book any space. For first element you are going to use 2 space, and whenever you are going to add a new element, it's only that time you are going to book space for that specific element. So memory usage is quite effective in case of linked list, but memory usage in case of arrays is not so effective. Now this point, whatever I've explained you know how a linked list works behind the scenes in the RAM and how an array works behind the scenes inside RAM. This point, if you have understood, it's very good. If you haven't understood, then don't worry about it, because this is a little tricky point to understand. If you are not able to digest it, if you are lost somewhere while I was explaining you, it's all okay. You have always an opportunity to talk to me after this session, one-on-one conversation. Let me there ask you questions about the same. Let me make sure that you have understood this concept fully. Alright, so don't worry. If you have understood this, it's okay. If you haven't understood, again it's okay, because in your one-on-one conversation, again I'm going to talk about the same with you, and I'm going to clarify all your doubts. I'm going to make sure that you have understood this. Now this is the way a linked list stores elements of a specific type in it, right? Now this linked list, whatever we have in Java collections, is basically works on the principle of DLL, doubly linked list. That's why I've written here a doubly linked list. So its element is going to point to the next. Its element is going to this element is going to point to the next. This element is going to point to the next, and this element is going to point to previous also. This element is also going to point to previous element also. So this is how this linked list concept works, and this is basically a DLL. This works on the principle known as doubly linked list. Now this is about how it works behind the scenes, but if you look at its use, it's going to be same like you saw in case of Arraylist vector. Yeah, it's going to be same. You have a linked list available. You are going to add elements to it. You are going to iterate through that, and you are going to remove any element, or you are going to get a specific element which is stored at a specific position. So if you specify here 2, what it's going to get you? 0, 1, 2. It's going to get you an element gone to. If you specify here 1, it's going to get you an element Gaurav, right? So everything is going to be same here. When you iterate through this, what it's going to do? It's going to allow you to iterate through, right? Like this. It's going to, first give you element Ankush, and then it's going to the next element, it's going to give you Gaurav, and then it's going to go to next element, it's going to give you Gontu. So it's basically going to maintain the order in which you are adding the elements, and it's definitely going to allow you duplicates. Means you can add here Ankush, and that's going to be added as a new node in this. So this is going to point to this, and this is going to point to null. Alright, the way to use a linked list is following this syntax. Now there's an advantage associated with the concept of a linked list. What is that advantage? No shifting needs to be done if an element is removed. Here it's not array list, it's linked list. Alright, so no shifting needs to be done if an element is removed from a linked list. So manipulation is very fast. Disadvantage: does not allow random access, so very slow. Now what are these 2 points? Let's talk about that. So this point, let's first see no shifting needs to be done. So this is RAM. I've stored Ankush, and then Gaurav, and then gone to, and then software. let's say I've stored this in the linked list. So how it's going to be stored in the RAM? Anywhere in the RAM it's going to create the node. Let's say it creates a node like this for Ankush, and then it's going to be pointed to null. But as soon as I'm going to add Gaurav there, it's going to create one more node there. It's going to write the Gaurav, it's going to be pointing to null, and this is going to be pointing to this. So it's going to contain the address of Gaurav, correct? And then it's in the same manner it's going to create another node for gontu. So this is basically going to point to this gontu, and software it's going to create one more node, say this one. So this gontu is going to basically point to this software, and this is going to point to null, right? So this is how it works. So one node points to another, another node points to another, another node points to another. So this is how it works. Now when you remove an element from the linked list, oh sorry, this is not a singly linked list, well this is doubly linked list. This concept is doubly linked list, so it's not going to occupy 2, it's going to occupy 3. So there is third element here, third element here, third element here. Okay, so this is this Gaurav is going to point to Ankush, this is going to point to Gaurav, and this is actually going to point to this. Well, this let me draw it again. Yeah, this is something we cannot understand, right? It's so clumsy. Okay, let me draw it again by taking less elements so that you see diagram with less complexity. This is a very important concept. If you are able to understand it, you are doing the best. And if you're not, don't worry about it, because anyways in your one-on-one conversation with me, and I'm going to make sure that you are able to understand all that. Alright, let's say I'm storing Ankush, Gaurav, and then third element gontu. Only 3 elements. Okay, so because this is linked list, so it's going to occupy 3 for this, anywhere in the RAM 3 for this, anywhere in the RAM let's say 3 here. So here let's say it stores Ankush, and here it stores Ankush, Gaurav, gontu. Okay, now this is going to point to this, and this is going to point to this, right? And also it's going to point in the previous direction also. So this particular thing is going to contain the address of this one, and this particular address is going to contain the address of this one, right? This is how DLL works. One node points to another, and another node also points back to the previous one, right? Now if you want to remove any element from here, let's say you want to remove Gaurav, what exactly you have to do? In order to remove this element Gaurav from here, all you need is to simply remove this, and what exactly you have to do is this address is going to point to this instead of this, and this address is actually going to point to this. So in order to remove this, what exactly you have to do, you have to just change the address, next address and previous address. Next address of Ankush you have to change, you have to point to gontu, and previous address of gontu you have to change, you have to point it to Ankush. So here next address of Ankush was actually Gaurav, previous address of gontu was Gaurav. So because you have removed it, so in order to remove that, what you have done, you have to simply change the next address to gontu and previous address to Ankush, and that's how you are able to delete. Now in order to delete, there's no shifting required, as we found in case of an array. So in case of an array, what happens, let's say this is an array, there are elements, say Ankush here, gontu here, this, that, so many elements are there, and if you have to remove this element in case of an array, what you have to do, you have to delete it, and then you have to shift all elements by one to their left, whatever elements are present to the right side of this element which you have just deleted. But in case of linked list, you are not required to do this. You are not required to perform this shifting operation. It's only that you have to change its address to the next element of this, and you have to change its previous address to the previous element of the element what you have to delete. So this way, a linked list is comparatively very fast in comparison to array. So in case of arrays, if you are removing any element, that is very slow. But in case of linked lists, in case of an array, if you are removing any element, that's very slow. But in case of linked list, if you are removing an element, comparatively that is very fast. So this is what this line means. Now what does this mean? Disadvantage: does not allow. This is linked list. Alright. It said does not allow random access, so very slow. What does it mean? It means if you have a linked list and there are 1 billion elements you have stored. Now if you have to access an element which is stored at 1 lakh position, what you would do? What JDK is going to do? It knows all elements are stored, one after another, right? So what it's going to do, it's simply going to go and hit the address at 1 lakh position, right? So it's going to go and hit upon the index 1 lakh and it's going to get that element, direct access. But if you look at the concept of linked list, in that case what's happening? In that case, elements are actually not stored one after another. In that case, how things are stored? First element is stored here, and the next element is stored here, and the next element is stored here. You don't know where that exactly, you don't know where exactly that next element is stored. So if you have to reach to 1 lakh element, then you cannot reach there directly because you don't know the address of that. How you would know the address of that element? You have to know its previous element, because its previous element is going to point to the next element. So in order to reach to 1 lakh element, you have to first go to first element. From there you have to understand where is its next element. You have to go to the next element, then you have to go to the next element of it, and finally, after traversing all those 1 lakh elements, you would finally reach to this 1 lakh element. So a lot of work has to be done in order to reach to a specific element, in order to retrieve a specific element. If you give a command, hey linked list, please get me an element which is stored at 1 lakh position, then in order to achieve that, it has to first go to first element, then from there it will get an address of next element, from there it will get an address of next element, so finally it would reach to 1 lakh element. But in case of an array, if you say, hey, get me the element what is stored at 1 lakh position, what it's going to do? It's going to go to the address where that array is stored, and there it's simply going to add 1 lakh to that, and straight forward it's going to go there without traversing through all these elements. So with that way, an array is very fast, but linked list is very slow. So here, because it does not allow random access linked list, it has to go in a sequential manner in order to access any element. So this is comparatively slower than an array concept. This is what I've written here. And then special case, whenever you store elements in the linked list, it's going to be retrieved only in the order in which you have stored elements. So if you have stored Ankush and then gone to, then Gaurav and then gone to, and then software. So all elements you can retrieve using iterator in the insertion order only. Okay, but if you want to rearrange linked list in any specific order, then the same concept applies what we learned in case of an array list. You have to either make use of comparable interface or comparator interface in case of a user defined object, And for a non-user defined object, well, comparable interface is already implemented there, so there's nothing that you have to do in order to get things in the ascending order. You have to simply make a call to collections dot sorry you have to simply make a call to collections dot sort method of linked list, and you have to just pass the required linked list object. If you are using comparator to that, you have to specify that comparator as second argument. If you are not using comparator, then you have to simply pass that element, but this object has to be of type comparable, means it has to implement comparable interface. If you are using a user defined object, say like country, then your country has to be implementing the comparable interface, and if that is not implementing comparable interface, then this is not allowed. Then you have to use comparator object along with that as second argument, and all this we learned, right? So everything works the same way as ArrayList or vector works. The only important point what you have to understand here is how a linked list is stored in the RAM. That's the only difference between an array and a linked list. So if someone asks you why you are using a linked list, maybe you are using linked list because of this advantage, that no shifting has to be done if you remove an element. So if your project demands removing elements very frequently in the container, then you should use linked list, because that's comparatively faster than ArrayList, right? And if you have to access, if you have to just access the elements, whatever you are storing in linked list, then there's no meaning to use linked list, because you have seen that this is very slow doing that access operation. If you have to just access more frequently any element what you have stored in your Java collection, then use ArrayList instead of that, right? So here I made a comparison of linked list and an array, correct? Now array is used by all data, all Java collections what we learned so far, like ArrayList internally uses an array, vector uses internally an array, stack uses internally an array, right? So whenever we say, it means all of these Java collections, ArrayList, vector and stack. And linked list is a different Java collection. And how it is different from these? The way it is managed in the RAM, the way it is stored in the RAM, and rest everything else is going to be same. So let me very quickly show you how this works, right, programmatically. Well, it's going to work exactly the way I showed you here in case of an ArrayList. You will not be able to figure out the difference here. The only difference is how it's stored in the memory, behind the scenes. But here programmatically you will not find any difference. So this is the demo for an ArrayList. Let me copy here. Let me copy from here the demo for the linked list. So this is the demo for that linked list. See, the way to create a linked list for any specific type is this. See here, linked list, non-primitive type, object name, the new linked list, non-primitive type, same the way we seen in any other Java collection. What is the way to store elements, to add elements to that? Same way, the way you added things in an ArrayList, by you making call to its add function. How to iterate through a linked list? Well, using an iterator concept. The same way you use things in case of an ArrayList. See, everything is same, except that in case of ArrayList, instead of an ArrayList, you are making use of linked list. If you want to sort this, you have to sort it by passing that object to collections.sort, and it's going to rearrange your strings in the ascending order. And after you have rearranged things in the ascending order, if you use iterator, it's going to get you objects, string objects in the ascending order. The way to remove things is also same. You have to specify the index what you want to remove, and it's going to remove. If you want to get an element, you have to make use of get function the same way we saw in case of the array list. The only difference is comparatively a remove function is very fast in case of linked list, and you know why, because there's no shifting required here. But get function is comparatively slower in linked list. Why? Because in order to reach to a specific index in the linked list, to a specific position in the linked list, you have to start from the beginning, and then you go to the next element, and then you have to go to the next element. Finally you would reach to the index what you desire. But in case of ArrayList, get is very fast because you know exactly where that element is stored. You know the elements in array are stored in the way, you know, one after another, not in the random fashion in the memory. So you know the address, you know, whatever you want, whatever index element you want, you can directly go to that index and get that element. So this is very fast. But remove is very slow in case of ArrayList. Why? Because shifting is required, right? The way I showed you linked list for strings, same way linked list for integer you can develop. See here, same way, no difference at all. You make use of linked list, you store integer objects to that, you can remove, you can iterate through that, you can sort that out, remove, and you do whatever you wish. Okay, now here I've added one more line at line number 49. What is this? For now you can ignore this, guys. What is this? Let me explain you after removing this from here. Well, what I've added here, in case of an array list, I showed you if you want to remove an element, then what you have to do, you have to specify the index what you want to remove. Now there is one more way available in case of an array list. The way is you write strings, then you choose remove, and inside that you don't specify the index. What you specify is the object. Let's say you want to remove Ankush from here. So this is the way you are going to write. So what it's going to do is going to search for this object inside this array list, and wherever it's going to find, it's going to delete that. So there are two ways you can remove an element, by specifying its index or by specifying that object itself. So same way I mentioned here. So you can remove an element from a linked list by specifying that exact object. So it's going to remove this element with value 1 integer, and you can also remove an element by specifying its index. So this is that. Okay, cool. The way I've showed you things for linked list for string and an integer type, same way you make use of a linked list for a user defined type, say country. So you would go on adding elements using its add function, then you would iterate through, and then if you want to sort, you can sort it by using collections.sort. You can pass directly countries linked list to that, but here it's mandatory that this countries object should be, this country object should be implementing comparable interface, because using comparable only it would be able to understand which object is lesser and which object is bigger, right? And using that it can arrange things in ascending order. But if you don't want this to go with the default strategy, means comparable strategy, to arrange things using that, you can always use comparator. So when you are using comparator, you say name comparator or population comparator with the linked list, it's going to arrange things in the ascending order using that comparator. So it's going to know which object is lesser than the other object. By using name comparator here, it's going to make use of population comparator to understand which object is lesser than another object. Same way, the way I showed you things for an array list. So guys, in all I want to just convey you a single point, that in order to learn Java collections, you have to just understand an array list fully. You have to devote time on how an array list works, and rest everything, whatever is available in Java collections, you can learn that very easily, because everything is just going to be same programmatically. there could be differences in the way that works behind the scenes. Any specific collection works behind the scenes, but programmatically everything is going to remain same. See, everything is same except the point that instead of an ArrayList, I'm making use of a linked list. In case of vector, instead of an ArrayList, I was using a word vector. In case of stack, I was using stack, and like that, right? So here we are iterating through, and then if we want to remove, we can remove like this an element by specifying its index. If we want to get an element, we can specify its position. If we want to remove a specific element, we can remove by specifying that object itself. For example, new country, India 20. So what this line is going to do is going to remove the object with the value India and 20. So this is how it's going to work. Got the point? So you can use remove by specifying the index, or you can use remove by specifying the country. Now, important point what you have to understand is when you're using remove function, this new country India and 20, right? It's needed that comparable interface has to be there in the country, because if comparable interface is not there, then it will not be able to figure out how these two objects are same. So comparable interface is going to give you the answer, which object is less than another one, which object is greater than another one, or which object is same. So if you have two country objects and if their population are same, their name can be different, but if their population is same, then it's going to give you 0. 0 means both are equal. So what it's going to do, if comparable interface is implemented there in the country, then it's going to simply figure out, hey, I have to do that equality based on this population 20, and wherever it's going to find 20 in this list, it's simply going to remove that. It doesn't matter what you have written for India, so you can write India or any other thing. It is not going to check that. It's simply going to remove an element with value 20. When it's removing an object of country, it's going to check if there any object present here whose value is 20. And how it knows that? Because of this comparable interface, because this comparable interface works on population. So you can always change it to name. So whatever you want to be the reason of equality of two objects, that's something you have to implement here in the compare to function, and a method of comparable interface. Okay. All right. So what is next? We have so far talked about the concept of an ArrayList, then we talked about linked list, then vector, and then stack. The next Java collection which we are going to study is a priority queue, and then ArrayDeque. So these are the things that we are going to study now. So what's a priority queue? Well, this is the priority queue. Guys, when we studied stack, what we learned? We learned that in a stack, you keep on adding elements and you are allowed to take the last element first. So it works on the principle of first in, last out. So whatever element you are going to include here first, you are allowed to take that element last when all other elements are removed. Now, there's one more concept available in programming that's known as queue. What is this concept? Queue is a concept where you keep on adding elements and you are allowed to take out the first element first. So first in, first out means if you added elements in this order, first this and then this and then this and then this, then queue is going to give you this element first, then this and then this and then this. And how stack works, it's going to give you first this element, then this element, then this element, and this element. So queue is basically right opposite to how stack works. This works on the principle first in last out, and this works on the principle first in first out. Now what is this priority queue? Priority queue is a very special type of a queue where how it works is the way I'm going to describe right now. So this is a priority queue. Alright, so let's say this is a priority queue and you have included here an element 10, and then you have included an element 20, then you have included an element 1, and then you have included an element 100, then 200, then say 150, and so on. How priority queue works is you add 10 to it, it's going to put 10 like this. And then after 10, if you include 20 to it, what it's going to do, it's going to find out which one is max, 10 or 20. And it's going to arrange things in such a way that this first element, whatever is present here, is going to be the max element. I'm sorry, minimum element. So here 10 is minimum, so it's going to add 20 here, and because 10 is less than 20, so it's going to put it to the left hand side. When you are going to add 1, because 1 is less than 20 and 1 is less than 10, so it's going to rearrange this whole thing in such a way that 1 is going to point to the first position, okay, and rest 10 and 20 are going to be present after that. Then once you add 100, then 100 is definitely greater than 1, so it's going to put 100 to this, and then 200 like that, and then 150 again, that is like just like this. So the idea is it's going to put always the minimum element at the first position, and then it's going to put remaining elements after that. So always you are going to include an element to it, it's going to rearrange things in it so that the minimum element is always pointing to the first position. So the idea is how queue works. It's always going to give you the first element, means the element which is present at the first position. So here when you are going to retrieve any element from a priority queue, it's going to give you first position. So here what's present at first position, it's 1. So once you take out 1 from here, then who is going to come to this position? Well, the second minimum element. Which is second minimum element out of these? Well, second one is 10. So it's now going to be occupied by 10. So now whenever you try to remove anything from a priority queue, it's going to again allow you to retrieve the first element. This is how the queue works. So it's going to allow you to retrieve 10. And once you remove 10, then which element is going to occupy this position? Definitely 20, because 20 is greater than 10 but lesser than all other elements. Then 20 you can retrieve. In the same manner, you go on retrieving things in the ascending order if you use a priority queue. So 1, 10, 20, and then 100, then 150, and then 200. So this is how a priority queue works. Now an important point what you have to understand. So far we have talked about the concept of an array list, then we talked about vector, then we talked about linked list, and finally stack. If you look at any of these Java collections, whatever we have studied here, whenever you add elements to any of these Java collections, all of these Java collections are going to maintain the order in which you are going to insert elements to it. So when you use iterator, so when you use an iterator over an array list, over a vector, or over a linked list, or even over a stack, I didn't show you how to make use of iterator over a stack, but you can always make use of an iterator over a stack. Okay, the way I shown you things for ArrayList, vector and linked list. So idea is whenever you use iterator on any of these Java collections, it's going to give you the records the way you have included, the way you have added in that Java collection. So whatever order you have maintained while adding elements to an ArrayList, vector or linked list or stack, iterator is going to give you order in that order. Iterator is going to give you all elements in that order, so it's going to maintain the order, right? Now if you are going to maintain, if this maintains the order, right, the way you include things, it's going to give you. If you want by any chance to sort things in any of these Java collections, what you do, you make use of collections, let me write it again. You make use of collections dot sort, and then what you do, you put here that ArrayList object or a vector object or a linked list object or a stack object. So if you want to rearrange things in the ascending order, then what you do is you put that particular Java collection object to that, and it's going to rearrange things. But how it's going to rearrange things? It's going to rearrange things if that object has implemented comparable interface, right? So for an ArrayList or a vector or a linked list or a stack, to arrange things in ascending order, it has to know whether one object is, it has to know how an object can be compared to another object. Okay, so in order to know how it can compare, it has to make it mandatory for an object to implement comparable interface, because if an object, say country, has implemented comparable interface, then it would have included its compare to function, isn't it? Right? And in that compare to function, you have written the logic using that JDK actually can compare one object with another object, and that's how it can arrange things in ascending order or descending order. And if by any chance you do not write comparable, you do not implement comparable, then the other way to sort things out is to write here comparator as second argument, right? In first argument you pass the Java collection, and second argument you pass comparator. So using comparator, using its compare function, JDK is going to understand how an object can be compared to another object, and based on that it's going to rearrange things in ascending order. Now in case of country object, in case of any user defined object, you have to implement comparable interface, or you have to write comparators separately. Okay, it's your choice. And in case of string object, in case of integer object, well, JDK people have given you string class and integer class, and inside these classes actually they have implemented comparable interface already. So there's no need for you to worry about. Only in case of user defined object you have to worry about whether you have to write comparable, whether you have to implement comparable interface, or you have to make use of comparator interface. But in case of other non-primitive types like string, integer, long, or any other type, you are not required to bother, because in any of those classes JDK has already implemented comparable interface. So it's going to JDK is going to make use of that comparable interface to compare string objects or integer objects or any other type of objects to sort them in the ascending order. Now why I'm telling you all that? Why I'm telling you all that is because of this priority queue. Priority queue works on the principle that when you are going to add elements to it, it's going to always rearrange things. So when you add 10 to it, it's going to put minimum element to its head, means to its first position. When you add 20, it's going to again rearrange things. When you are going to add 1, it's again going to rearrange things. So 1 will be, 1 will be moved to the head of this priority queue, means to the first position. So likewise, So whichever is the minimum element, that has to be present at the head, at the first position. Now for JDK to understand which element, which object actually has to come first, it's mandatory that it's going to do that using comparable, using compare to method. If compare to method is present in that user defined object, say country, then it can compare this object with this object. And that's how it can know which object has to be present at the head. And if you are, say, putting integer objects, the way I'm showing you here things, because integer class is already implemented comparable. So JDK is going to use its compare to method to find out which object is lesser and which object is bigger. So which one is bigger, 1 is bigger or 20 is bigger, it's written in compare to method of comparable interface in the integer class. So accordingly it's going to put the minimum there. In the similar manner, if you are comparing string objects, if you are going to include string objects in it, now again it's going to move the minimum element of all, minimum object of all to the head. Now how it knows which one is minimum in this string, right? It will know because string object, string class, whatever JDK has provided, has already implemented the comparable interface in it. And in its compare to method, it has written the logic how these two objects can be compared. So it has written the logic that Ankush is minimum. Ankush is smaller than Gaurav. Why? Because lexicologically it's smaller. Dictionary order wise it's smaller. A is smaller than G, so it will decide Ankush is minimum. So idea is PriorityQueue will always have to arrange things based on which element is minimum and which element is maximum. It has to compare two objects to decide which object is minimum and that it has to keep at the head, that it has to keep at the first position. And for that it makes it mandatory that whatever object you are storing in a PriorityQueue, that has to implement comparable interface. Now in case of integer, string or any other non-primitive type other than user defined types, already JDK people have implemented comparable interface, so no worries about that point. But if you're writing an object yourself, if you're writing a user defined class yourself like country, then it's mandatory that comparable interface has to be there. Without that it cannot work. Without that PriorityQueue cannot work because it has to put minimum element at the starting. Now PriorityQueue makes it mandatory for you to implement comparable. If you do not implement in that user defined object or whatever object you are storing, it is not going to work. But in case of ArrayList, in case of linked list, in case of vector or in case of stack, you use comparable interface or comparator interface only and only when you make use of collections.sort method. So if you're not going to make use of collections.sort method, then it's not mandatory for any of the objects that you are going to store here are going to be implementing comparable interface, or there's no need to write comparators separately. So you are going to use comparable interface with ArrayList, linked list, vector or stack only and only when you are going to use collections.sort method. But PriorityQueue makes it mandatory that you have to write comparable, because using its compare to method only it will know which object is bigger and which object is smaller, because this is how it works. Alright, so that's how it works, nothing more. So this is the syntax to write a PriorityQueue, and it's going to allow you to retrieve the priority item first, means the minimum element first. Priority means minimum. Okay, and how it will know which one is minimum? By using the comparable interface, by using the compare to method in that object. So let me very quickly show you the demo for the same. So far we looked at linked list. Now I'm gonna show you how you can make use of a PriorityQueue. Well, that's also going to be same, nothing much, not much difference you are going to observe. Yes, concept wise you'll find a difference. So this is the PriorityQueue. Now the important point which you have to understand, one more important point, all of these ArrayList, linked list, vector and stack, all of these 4 Java collections come under a group known as lists. So these all are called as lists. The way this list works is different from the way this list works. The way this list works different from the way this list works. The way this list works is different from the way this list works. But overall, all of these Java collections are lists. Now what we are going to study is a queue. So this is another category. So let me do one thing. Let me create a new package over here. Queues, and let me copy the PriorityQueue demo class over here, and I have to change the package name because this is coming under queues, and here I have to press Ctrl+Shift+O in order to get the required imports on top of it. Cool, all is done. Now let's understand how to make use of a priority queue. Well, the way you make use of a priority queue is very simple. You create a priority queue this way. This is the syntax, non-primitive type. So if you want to create a priority queue for a string object, then you write string data type here and then priority queue. You add elements to it using its add function, and then if you make use of an iterator over a priority queue, then it's not going to give you things in any specific order. If you use an iterator over an array list or a linked list or a vector or a stack, I didn't show you how to use an iterator over a stack, but the way I showed you how to use an iterator with array list, linked list or vector, same way you can use an iterator with the stack. Now, the way iterator works with all of these is it's going to display records in the manner you have inserted records in the same order. So if you have added elements in a specific order, Ankush, then Gontu, and then Ankush Gaurav, and then Gontu, and then software, iterator is going to display things in that same order. But in case of priority queue, if you use an iterator, it's not going to give you things in that order. It's going to give you things in a random manner that's not defined. So it may happen it's going to give you Ankush first and then Gontu second, and likewise. It's not going to give you things in any specific order. Priority queue. Okay, that's what I've written here. If you use an iterator over a priority queue, it's not going to give you things in any specific order. But if you use a poll method of a priority queue, then it's going to retrieve you the minimum element what you have stored in the priority queue. So whichever is minimum, it's going to print that. So here I've got the size of this priority queue, which is nothing but 4, and here I'm trying to iterate 4 times, and every time I'm polling, I'm making call to its poll function. So what it's going to do, it's simply going to retrieve me the minimum of all. So which one is minimum? Well, Ankush is minimum lexicologically, right? And how it knows Ankush is minimum? Well, in string non-primitive data type, comparable interface is already implemented. So by looking at its compare to method, it's going to understand which one is minimum. So it's going to display. So first time it's going to display Ankush, and then what it's going to display? Well, out of Gaurav and others, which one is minimum? I feel Gontu is minimum. So it's going to compare G with G, O with O, O with O, and N with R. N comes first, so this comes as second. And after that Gaurav is going to come, and then after that series is going to come. So this is how dictionary order works. This is how lexicologically it's going to give you things. So it's going to print first Ankush, then Gontu, and then Gaurav, and then series. So this is how this is going to work. Priority queue is going to work. Let me show you. See here, when I use iterator, I got things in this order: Ankush, Gaurav, Gontu, and series. Okay, here it's a chance that it has given me things in this order, the order which I just used here: Ankush, Gaurav, Gontu, and series. but it doesn't guarantee that always it's going to give you things in this order. Maybe when you are going to put 1000 elements in it and you use iterate, it's not going to give you things in that order. Maybe you add specific elements to it, it's not going to give you things in that order. But when you use poll, that time it's always going to give you minimum element first. So first it displayed Ankush, then Gontu, and then Gaurav, and then series. Same is the case with the integer. This is how you create an integer priority queue. To add elements, you use its add function, and then you use iterator. When you use iterator, again it doesn't give you guarantee. 1, 50, 20 and 110. See, this is what it is displaying when you are using iterator, and the order in which you have put elements in this priority queue is 1 and then 1, 1, 0 and then 20 and then 50. It's giving you 1 then 50. So no specific order it's going to maintain. No order, no specific order is maintained. But when you use poll, then it's always going to give you minimum element first. Minimum element is called as the priority element, and that's what it's displaying. 1 then 20 and then 50 and then 110. This is how this works. Same is the case with the country priority queue. So here I've shown you things with a user defined type country which we have created. See here, this is the type, and we have used comparable interface. Using compare to method, it's going to compare whether one string object, whether one country object is smaller, bigger or equal to than other country object, and that's how it's going to rearrange country objects in it always when you are going to add one more element to that, so that always minimum country object is going to stay at the head using its comparable interface, using its compare to method. So again, iterator is not going to display things in any specific order, but poll is going to always give you minimum element. Now the compare to method, what we have written, is working based on the population. So here when you are using this country object with this priority, it's going to always point the country object with minimum population at the head, at the first position. So which one is minimum? Bangladesh. So first it's going to print Bangladesh, then it's going to print India, then it's going to print Nepal, and then it's going to print America. So this is how it works. Make sense? Let me show you this working. See, first it displayed Bangladesh, then India, and then Nepal, and then America when you use poll. But when you do not use poll, that time what results it's going to print, that's those results happen to be same, I believe, Bangladesh, India, Nepal and America, but there is no guarantee. There is no guarantee what JDK gives. It may happen when you run next time, this result is going to come differently, or when you are using 1000 or 2000 elements or different kind of objects, country objects with different values, it's not going to maintain any specific order. But this is always going to be giving results in the order that minimum element, ascending order basically. This, then this, then this, and then this, right? So this is how this whole thing works. So the point which you have to understand is, you keep on adding things to any of the Java collections, and anytime when you want things to be arranged in the ascending order, then it's mandatory for you to have comparable interface there. In case of all these lists, ArrayList, LinkedList, stack and vector, it's not mandatory that you have to implement comparable interface. If you're not using comparable interface, then there's one more option. You can write a comparator, and when you have to use collections.sort method, it's only then you have to worry about ascending order. You have to worry about whether you have implemented comparable interface or you have written comparator or not. Otherwise you don't need to worry about it. But in case of priority queue, there's no comparator you have to use. It's going to sort things based on only one thing, and that is comparable. If you do not have comparable interface, then when you run this, it's not going to allow you to run. So it's going to display results for strings because string object has got comparable interface already implemented by JDK. Integer object has already implemented comparable interface. But country, here we have just removed the comparable interface. So when we are going to run, it's going to give a complaint that it cannot run because comparable interface it didn't find in country. Because using comparable interface only, it has to sort, and then it has to get us the minimum element always. See here, it's giving an error that comparable interface is not there. So when we have comparable interface, it is not going to give us any problem. Everything is cool. So this is all about the priority queue. Now the way we have learned about the priority queue, same way there is one more concept available known as ArrayDeque. Now how this concept works? Well, there is no concept of ascending order, means priority element means minimum element. Here it works on the generic principle of a queue. So whatever element you are adding, say 10, 20, then 1, and then 100, and then say 200. So the way you are adding elements, same order is going to be maintained inside it. Same order. It's just that when you want to retrieve any element from an ArrayDeque Java collection, then it's going to allow you to take out the first element from it, the next element from it, and then next element from it, and then next element from it, and then next element from it. So it's a normal queue basically. Excuse me. So in case of priority queue, what happens? Every time you add element, it's going to be rearranged so that minimum element comes to the first position. But when you add things in the ArrayDeque, it's going to be added in a normal fashion. Its order is going to be maintained. But here, when you want to retrieve things, it's always going to give you the element which is present at first position. So you are allowed to use it like a normal queue, not like a priority queue. You are allowed to use an ArrayDeque like a normal queue, where you are going to take out first in, first out. Whatever element you are adding first, you are allowed to take that out first. Now you can use an ArrayDeque as a queue not from one side. You can use it from either side. Now what does it mean? Means you can specify that you want to use it like a queue from this side or from this side. So this is the first element and this is the last element, right? Now if you use it as a queue from this side, then what's going to happen? Then it's going to allow you to take out the element 10 first, and then 20 first, and then 1 first, then 1, and then 100, and then 200. But if you say that I don't want to use queue, it as a queue from this side, from the order which I've used to insert elements into the queue, I want to use it like a queue from this side. Alright. So that way it's going to allow you to retrieve this element first and then this element and this. So you can use an ArrayDeque like a queue from both sides, from this end and from this end. So if you want to retrieve an element, so in case of a priority queue, what you were doing, you were using its poll method. And what poll method was giving you? Poll method was giving you this first element, and there it was storing always minimum element, right? Now here, in case of ArrayDeque, what you have to do is you have to use another method which is going to give you results. You want this element or this element. How it works? Let me show you this. ArrayDeque. Yeah, so let's copy this and put it here. In our demo, this also comes under the category of queues. So let me put there. Let us change the package name for this, QUE UES, and then it means it's imports and all of them have included by pressing Ctrl+Shift+O. Now how it works, see, this is how you create an ArrayDeque string object. To add elements, you make use of its add method, and then you use iterator. Now in case of PriorityQueue, if you use iterator, it's not going to give you things in any specific order. In the same manner, if you use iterator over an ArrayDeque Java collection, then again it's not going to give you in any specific order. That order is not guaranteed. Okay, but if you use the poll method of an ArrayDeque, poll first, what result it's going to give you? Poll first is going to give you results, this way, from left to right. Means it's going to allow you to retrieve first element, and then this element, first element. When you remove 10, then this becomes first element. When you remove this, then this becomes first element. When you remove this, this becomes first element. When you remove this, this becomes first element. So that's how it's going to give you results, poll first. But instead of poll first, you can always make a call to its poll last. What poll last will allow you? Poll last will allow you to retrieve the last element first. So it's going to allow you to take out elements from an ArrayDeque from right hand side. So you are going to be allowed to retrieve 200 first. When it's removed, then this will become the last element. You can remove this, then this becomes last element. So when you use ArrayDeque from right to left order, then this becomes stack, isn't it? So this is how stack works. So when you use it from right hand side, then it's like first in and last out, which is what is stack. So when you make use of an ArrayDeque using its poll last function, then you are basically using an ArrayDeque like a stack. And when you are calling its only poll first function, then you are actually using ArrayDeque like a queue. So this is just an advantage in ArrayDeque, nothing more. Alright, so it's going to display first element, and then when you are going to remove that, then another element will become first. Likewise, whole ArrayDeque it's going to display. Here I'm getting the size, and here I'm displaying. Important point what you have to understand, in case of queues, when you use iterator, it's not going to give you results in any specific order. But in case of lists, if you're going to use iterator, then it's going to maintain the order in which you have included the elements. Make sense? Now here string, the way I have shown you the ArrayDeque concept for a string type, same way you can make use of an ArrayDeque for an integer type. Here you are adding elements to it, then you are iterating to that, and then you are polling its first. You are using it like a queue, so you are making call to its poll first. If you want to make use of an ArrayDeque like a stack, then you have to write poll last, right? And then country object. So you are adding all country objects to it, then you are iterating. It's not going to give you things in any specific order. You're getting the size of it, then you are displaying. Again, you are using it like a queue, where first in first out strategy is what we are using. If we are writing here poll last, then we are actually using first in last out strategy, which is nothing but stack strategy. So here we are using first in first out, means queue strategy. Now important point what you have to understand is ArrayDeque just displays things the order in which you are going to insert things. All right, it's going to allow you to use it like a queue or a stack, but it's not going to compare two objects. It's not going to display things in any order, specific order like ascending or descending order. It's just going to follow the order in which you have inserted elements to an ArrayDeque. So it's never going to compare two objects. When it's never going to compare two objects, it means it's never going to make it mandatory for you to implement comparable interface or comparator interface. So for an ArrayDeque, there's no need to use comparable or comparator interface, because it's not going to compare any object anytime, because it's never going to sort things for you. But in case of PriorityQueue, it's mandatory for you to implement the comparable interface. In string, integer, or in any other non-primitive data type which is given to you by Java, comparable interface is already implemented, so you are not required to worry about that. But in case of any user-defined object that you write, you have to make sure that you write comparable interface, otherwise things are not going to work. But here there is no need to do that. So this is all about an ArrayDeque concept. Allows you to retrieve in FIFO, can be used as a queue from either end. Means if you use from left to right, then that use as a queue. If you use from right to left, then that becomes a stack. Or maybe in general you can say you can use it as a queue from either end, from left to right or from right to left. So what all things we have learned today? Well, Arraylist we have seen, LinkedList, vector, stack, and then PriorityQueue, and then ArrayDeque. So we have finished up till this level. Now in the next session we're going to talk about hash set, linked hash set, tree set, hash map, linked hash map, and tree map. Well guys, this is also going to be very easy. What I'm doing actually after Arraylist, I'm simply showing you things. I'm not explaining much concepts, and whatever concepts I'm explaining thereby are actually very easy, like PriorityQueue, like stack, and these are very easy concepts. How a linked list is stored, how an array list is stored. So point is, you learn Arraylist, and after that things are going to be very easy for you to learn. And it's all practice. Don't try to remember things forcefully. Try to remember things with your practice. After this session, come for one-on-one conversation. I'm going to make you very much comfortable in whatever we have studied so far. Alright. So if by any chance you have lost somewhere while studying, or you are not able to understand any specific concept, or you just got confused anywhere, you know what to do. Just take a short break after this session, according to your schedule, and come for one-on-one conversation with me, and I'm gonna make sure you're gonna rock with this topic, Java collections. All right, so tomorrow we're gonna talk about rest of the Java collections. Cool. Good guys, thank you for joining me. Have a wonderful day.